So for today's lesson, I'm going to talk about integration by trigonometric substitution. I were not able to see the recording, so I'm going to start again with this. So this is another technique of integration. And so similar to algebraic substitution, of course, and the only difference that instead of replacing, for instance, a simple variable, a certain expression, we're going to replace a certain expression by trigonometric function. So for instance, in terms of sine, in terms of tangent, in terms of secant. Trigonometric substitution is a technique of integration that makes use of trigonometric functions. It is generally useful for integrals involving expressions of the forms a squared minus u squared. A here is a constant. Normally we take it positive. U is a function, let's say of x, but not always x, of course. It can be in terms of y, w, any letter. And then another possible expression, a squared plus u squared. So we have u squared minus a squared. So if you have any of these forms, then possible that you will able to solve it by trigonometric substitution. We apply trigonometric substitution if you cannot solve it using the previous formulas that we had in basic integration, especially those formulas leading to inverse trigonometric functions. Possible also if you cannot solve it by general power formula, integral of du over u, but definitely not exponential, no? Although possible that our u here is exponential also. Okay. So let u be equal to f of x and assume that this is a differentiable function and a is a real constant greater than 0. If the integrand involves the expression a squared minus u squared, try the substitution u equals a sine theta. Theta here is restricted to negative pi over 2 to pi over 2. Du is equal to a cosine theta d theta. So again, take note that u here is the square root of this u squared in the form a squared minus u squared. And then don't forget, of course, to take its du. And that is equal to a times cosine theta d theta. So you're going to express the integrand together with the du in terms of theta, involving, of course, trigonometric function, sine, and then for the du, cosine. If the integrand involves a squared plus u squared, so this is what you're going to try. U equals a tangent theta this time. So where theta is between negative pi over 2 to pi over 2. And then du is equal to a secant squared theta d theta. And then the last one, if the form involves is a squared minus, again, if the form involved is a squared minus u squared minus a squared, try the substitution u equals a secant theta. So see the difference between the first one and the second one. The first one starts with constant squared followed by u squared. So, and then this third one, function squared minus a squared. The substitution that you're going to try, u equals a secant theta, where theta is from 0 to less than pi over 2 or greater than pi to less than 3 pi over 2. Now, these restrictions are important so that when you have, for instance, in number 1, in the first substitution, if cosine theta is involved in the radical and it is, let's say, cosine squared and you take the square root, so guaranteed that you just have cosine theta because cosine is always positive in the first and fourth quadrant. So no need for the absolute value or for cosine theta when you get rid of this from the radical. So again, if you have cosine squared theta, you just have, when you take the square root, cosine theta, not any more absolute value of cosine theta. Similar to secant theta, no? So for second substitution, you will have a trigonometric function secant squared in the radical, so especially square root. And if you take the square root of secant squared, so you just have secant theta, for instance, because secant is positive again in the first and fourth quadrant. Now, for the third, what you will have is a trigonometric function in the form, for instance, tangent squared in the radical, especially square root. If you have square root of tangent squared theta, then you take the square root of that, just tangent theta, not anymore absolute value of tangent theta, because tangent theta is always positive in the first quadrant and in the third quadrant. So that's the reason why these restrictions are provided. So in solving integrals by trigonometric substitution, you don't need to put these restrictions. So understood that these are what we're going to employ, okay? So let us have particular example. By the way, so the differential of u is equal to, for the third, a secant theta tangent theta d theta. So let us have the following examples. So let's say we are asked to evaluate number 1, integral of dx over 4 minus x squared quantity to the 3 halves. Now this integral cannot be solved using general power formula, because if I'm going to bring it up, the exponent is to the negative 3 halves and possible u 4 minus x squared. Unfortunately, if I take the differential of that, I will have negative 2x dx. So we don't have x, so that's the problem. No, the constant can be provided, but x, you cannot have it inside and then balance outside. And definitely it's not integral of du over u. And if you're going to have it, for instance, integral leading to inverse sine, so it's not, because it's to the 3 halves in the denominator and not to the 1/2 or square root of 4 minus x squared. It is to the 3 halves. So let's try if substitution will work here. Okay, guys? So our a here is what? A squared is 4, okay? What about u squared? Our u squared is equal to x squared. So meaning, our a here is 2, while u, we have x. So what we're going to have in the suggestion, our u, which is x, we are going to replace it by our u, again, which is x, to be replaced by a, that is 2, sine of theta. Okay? So what about the differential of x? So that is 2 cosine theta d theta. Okay, guys? So let us express this expression inside in terms of sine and this 2 cosine theta d theta, no? The integral now becomes integral of what about dx, guys? What is dx? 2 cosine theta d theta. Am I right, guys? Guys. And then for the denominator, we have 4 minus x squared is square of this. So that is 4 sine squared theta raised to 3 halves. Let's try to express this difference in terms of one term, no? That is in terms of cosine. Remember, we have 1 minus sine squared is equal to cosine squared. If I'm going to factor out 4 here inside, I will get 4, then multiplied by 1 minus sine squared theta. Am I right, guys? Guys, are you still there, guys? Guys?
Yes, po.
Yes, sir.
Sin theta in the numerator, d theta. So again, but what is 1 minus sine squared? So that is equal to?
Cosine squared.
So getting integral of, let's copy the numerator. So the numerator is 2 cosine theta d theta. And the denominator, we have 4 raised to 3 halves. 4 raised to 3 halves is 2 cubed, no? And 2 cubed is 8. Okay? So square root of 4, 2 raised to 3, 8. And then 1 minus sine squared, that is cosine squared. Square root is 2 raised to 3. So we have cosine cubed theta. Okay, guys? So from here, so we now have 2 over 8, that's 1/4. Integral of 1 over cosine squared. Bring it up. So that is what? Oh. Guys, if I'm going to bring that up, this cosine squared, what is that equal to, guys?
Negative cosine squared po.
Equals secant squared theta, na? So again, d theta over cosine squared theta is secant squared theta d theta. And this has an exact integral now, no? We can evaluate this now. So that is under integration of trigonometric function. What is the integral of secant squared theta d theta?
Tangent theta, sir.
Theta, no? Plus c. But our original variable is in terms of x. So let us express tangent in terms of x. So from this representation of us, we say that x is equal to 2 sine theta. No? So let's draw a triangle out of this. The associated triangle out of this is this triangle, and it has the following parts. So let's label the sides. You can draw an arbitrary right triangle. Yeah. So this is right triangle. Now, here, sine theta is x over 2. Okay? So again, what is sine theta, guys? Sine theta is equal to, from here, from our representation, x over 2. Okay? So let's define tangent theta out of this sine theta, which is equal to x over 2. Remember, in your trigonometry, given one function, you can find the other function. No? If you know the equivalent of this, so you can find the remaining functions. In particular, we can find tangent. No? So sine theta, this is opposite over what? Hypotenuse. If this is our theta, so this is opposite, and this is the hypotenuse. So that we can have for the remaining side, that is square of the hypotenuse minus the square of this leg. So we now have this adjacent, no? Square root of 4 minus x squared. Notice that this 4 minus x squared is the one that is involved in the given integral. Okay? So how do we read the value of tangent function, guys? Tangent theta is equal to, that is opposite over adjacent. Adjacent is square root of 4 minus x squared. Opposite is x, okay? So that is plus c. So or x over square root of four minus x squared. Oh, that's it. Then plus c. Any question with this, guys? Guys, do you have any question with that?
None, sir.
Okay, so let us have another one. So let's say I have number 2, integral of let me see what we had last time. So x cubed, no? X cubed is square root of 9 plus x squared dx. By the way, there are integrals that trigonometric substitution can solve, which can be solved also using algebraic substitution. So you just try which one is better. So in this case, our a squared is equal to 9. Therefore, what is our a? Our A is 3, no? And our U squared here is X squared, so that our U is X, no? Okay, guys? Then we let what? We let U, which is X, equal to, since this takes the form of A squared plus U squared, so I'm going to have tangent. So A, but what is our A, guys? 3. Then tangent theta. For the differential of X, we have 3 secant squared theta d theta. Okay? So let us now express everything inside integral in terms of these functions, no? Tangent and secant squared. So we have integral of x cubed. So x cubed is equal to 27 tangent cubed. We have to cube this 3 tangent theta. So again, that is 27 tangent cubed times square root of, what about this 9 plus x squared? That is 9 plus, so here we have square of x. So that is 9 tangent is tangent theta, 9 tangent squared theta. Internet is unstable. Eh, kailan na ba naman naging stable ang internet sa Philippines? Nakalagay. So we have dx is equal to 3. So rather 3 secant squared theta d theta. Okay? So let's check if what I am writing is correct. So let's now simplify. 27 times 3, that is equal to what, guys? 27 times 3.
81, sir.
27 times 3 is 81. Let's put it out. Then integral of tangent cubed theta. Inside radical, I can factor out 9. So then remaining we have 1 plus tangent squared theta. But what is 1 plus tangent squared theta, guys? So that is equal to what, guys? Secant squared, right? Integral of tangent cube theta times, so this is 3 secant squared. Yan. Square root of, so square root of 9 is 3. So secant squared theta times secant squared theta d theta. So this is equal to 3 times 81. 3 times 81 is 243. Integral of, this is tangent cubed theta times the square root of secant squared theta is secant theta. Again, we don't need absolute value. Why? Because secant function is always positive in the first and fourth quadrant, which is the restriction in our tangent theta, no? For our theta, I mean. So if you have this representation, so this is secant theta times secant getting secant cube. Then d theta. Am I right, guys? Do you still remember what case is this in trigonometric transformations? Guys, what is that in the technique called trigonometric transformation? Guys, you're going to what? You're going to split this, no? So let's get one tangent and one secant from each. So this is equal to 243 integral of, so from here, we're going to segregate one tangent and one secant. So this is now tangent squared, theta, times secant theta, so squared, no? And this is what we segregated, one linear secant and one linear tangent, which will serve later as the differential of secant function. No? So it means we have to express this in terms of what? Secant this tangent squared. This is case 5 in our technique called integration by trigonometric substitution, transformation. So we have integral of. So let's transform this. So this is what we're going to transform. So this part, transform this. And that is equal to secant squared theta minus 1. Am I correct, guys? Multiplied by secant squared theta, then times secant theta tangent theta, d theta. Okay? So let's now distribute this secant squared inside. So we have secant to the fourth theta minus secant squared theta times secant theta tangent theta, d theta. Okay? So here, I can evaluate this using general power formula, no? My u here is secant, my n is 4, and this will serve as my differential. In the second integral that I'm going to have, this is u secant theta, so same, no? And then n is 2, so and then this is du. Okay, guys? So this is 243 integral of secant to the fourth theta u to the n, and this is my du. And then for the second integral, so minus 243 integral of secant squared theta times secant theta tangent theta d theta. Okay, so by integration using general power formula, so we have 243 u to the n du. So u to the n plus 1 all over n plus 1 minus 243 times, again, u to the n du. What's the integral? U to the n plus 1 all over n plus 1 plus c. Okay, guys? So, but what is secant theta, guys? So let's have from the triangle, right triangle that we can associate in our representation. So let me draw a triangle. So we have this right triangle. Okay. And if this is theta, so how do we define tangent theta? Tangent theta, guys, is equal to what? That is equal to what, guys? Tangent theta. X over 3. So how do we define tangent? Opposite over adjacent. So we can now solve for this hypotenuse. Square of 3, that is 9, plus square of x. So we have x squared, getting square root of 9 plus x squared. So what is secant theta? That is hypotenuse over adjacent. So 243 over 5. So 243 over 5 times secant is square root of 9 plus x squared all over, so that is over 3, no? And we raise this to what? To 5. So getting, so this 3 is raised to 5, which is in the denominator, multiplied to 243, 243 divided by 3 raised to 5. So it is equal to 1. So again, 3 raised to 5. Check this, guys, if I'm correct. So 243, that is cancelled with what? 243 here. Okay, guys? So this 243 is now cancelled out with this because this is raised to 5. So leaving 1/5. 1/5. Then this means 9 plus x squared raised to 5 halves, no? 9 plus x squared raised to 5 halves. Okay, guys? What about the second integral, guys? Minus 243 over 3 is what? Guys, that is 243 divided by 3. That is equal to 81. So 81 times secant theta quantity cubed. Again, secant theta is square root of 9 plus x squared all over, or 3 quantity to the third. Okay, so this is 3 cubed. 3 cubed is 27, 81 divided by 27, that is negative 3. Negative 81 divided by 3, that is 3 cubed, that is negative 3, multiplied by 9 minus x squared raised to, this is 3 halves, no? Is that clear, guys? So plus c, no? Did you understand that, guys?
Yes, sir.
Now you can factor out 1/5. If I factor out 1/5, so actually this is already the answer, no? But I think we can express it in a better form, in factored form. If you express this in factored form, we have 1/5 multiplied by 9 plus x squared raised to 3 halves. And then we're going to have here, remaining is what? Anong matitira dito, guys? If I factor out 9 plus x squared, magiging 9 plus x squared raised to 1, no? So to complete 5 halves, minus what about here? Anong matitira? So I have 15, no? 15. Am I correct, guys? Yan, 15 plus c. Okay? Did you get that, guys? And simplifying further, actually this is already accepted. But if you want in factored form, let's say it's a multiple choice, so you have to have an alternative form. You should know how to write that in other form. So this is 9 minus 15, and that is negative 6, so plus x squared. So finally, we have 1 over 5 times 9 plus x squared raised to 3 halves multiplied to 6 minus x squared plus c. Okay? Sorry, that is x squared minus 6, no? So x squared minus 6 rather. So plus c. Let me check. Okay, x squared minus 6. Then plus c. Okay, guys? Hi, guys. Any questions so far?
None po, sir.
Yun. May nasumagot. So let's have number 3. Yan. Square root of 9 y squared minus 4 over y dy. What about this? So here our u squared is 9y squared. So we let, you can go directly, we let 3y, so that is our u. U equals, so since this takes the form of u squared minus a squared, let's try the substitution. 3y times what, guys? 2, which is our a, because a squared is 4. So secant this time, because the one that is in the first term, function, no? Minus constant squared. So function squared minus constant squared. So we have this suggested substitution. A secant theta. So let's get the differential. 3 dy is equal to 2 secant theta tangent theta d theta. Am I correct, guys? So what is dy? If I'm going to solve for dy here, so this is 2/3 of secant theta tangent theta. Then d theta, okay? So the integral now becomes integral of, let's have for the numerator, what are we going to have for the numerator, guys? Gonzalez. Gonzalez. Not around. 9y squared. So that is 4 secant squared, because we have to square this 3y. That is 4 secant squared. So 4 secant squared theta minus 4. So that is 4, 9y squared minus 4. What about dy, guys? 2/3 secant theta tangent theta. D theta. And then here we have what? Hey guys, what is y, guys? Guys, oh, here, 2/3, no? So 2/3, 2/3 of secant theta. Can you follow, guys?
Yes, sir.
Yes po, sir.
So this is cancelled with this, no? Cancelled out with this. But what is 4 secant squared theta minus 4? You should know by this time how to do this, no? Mentally, this is 4 tangent squared, because if I factor out 4, that is secant squared theta minus 1. And then that gives us 4 tangent squared theta. Okay, guys? So as you become familiar, so you should be fast now this time because it's the third. Again, we have what? Integral of here. So I have to, no? Put the 2 out of the integral. And this is square root of 4 tangent squared theta. Tangent squared theta. Again, why is it that this is equal to 4 tangent squared theta? Because secant squared theta minus 1 is tangent squared theta after factoring out 4, no? And then we copy 4. Then times tangent theta. Is that correct, children? Hi, guys. So we now have... Ay, wala na palang 2, no? Na-cancel na, sorry. Oh, hindi kayo nakikinig. Kita nyo, hindi nyo napapansin. Because this is canceled everything here. So we now have integral of what is the square root of these 2 tangent to tangent theta times tangent theta, that is tangent squared theta, d theta. So this is a simple transformation of this takes the form of tangent to the n. So we have integral of that. You have to transform that into secant squared theta minus 1. This is now by trigonometric transformation. This is basic trigonometric transformation. D theta. So I can now evaluate its integral that will be formed out of this. So 2 times, what about here? Tangent theta and secant squared theta d theta. That is a direct formula. Negative 1 d theta, the integral is theta, no? Negative theta plus c. So getting 2 times, what is, again guys, tangent function? Out of this, we have, let's draw a triangle from here. So I can draw a triangle. This is the associated triangle. Theta. And how do we define secant function? From our representation, we have 3y over 2. So again, what is secant theta, guys? 3y over 2. So how do we define secant? That is hypotenuse 3y over adjacent. So 2 here. So I can solve for this part. Square of 3y, that is 9y squared, minus 4. Actually, we just copy this thing, no? So we can now express this in terms of y na, no? 2 tangent. What is tangent? Opposite over adjacent. adjacent is 2. Minus 2 times theta. So from here, you see secant theta is equal to 3y over 2. I can solve for theta here. Theta is inverse secant of 3y over 2. Can you follow, guys? Okay, guys. Guys, Serrano.
Yes po, sir.
Actually, you can have options for this theta, no? You have how many options? Add us 5 options. This is the first option. There are still 5 options. Okay? So all in all, 6 actually. You can get it from the original representation that you have. But if you're going to look at this, so this is your tangent, no? If you solve for theta, theta is also equal to inverse tangent of this square root. So sometimes, if you're going to look at the book, so you will not find this sometimes. So what you will find is the one that is similar to what? To this expression. So if you use tangent theta here, possible that this is inverse tangent, but you will have a square root of 9y squared minus 4 over 2 inside here. Okay, guys? Yeah, that is an option. And then if you have, let's say, sine theta, yeah, your sine theta is this radical over 3y. Then you can solve for theta. That is this radical over 3y. Okay, so you have many options. So simplifying, we have a square root of 9y squared minus 4 minus secant or inverse of 3y over 2. Okay, guys? Let me put grouping symbols here. Plus C. Oh, that's it. Is that clear, guys? Guys?
Yes, sir.
Times 2, no? May times 2 dito. Okay, guys. Hindi naman kayo nakikinig. Minus 2 times minus 2 secant. Okay. Let's have number 4. I think we can solve 2 more. What about this integral? Evaluate the integral of ln squared x dx, ln squared x dx over x times 1 minus ln squared x quantity to the 1/2. Okay? So this is actually square root of 1 minus ln squared x, which is the one same way the denominator in integration leading to inverse trigonometric tangent, no? But unfortunately, merong ln squared here. So that makes it not possible by such, no? By such basic integration. So let us have trigonometric substitution here. So we let this ln x, because this is a squared minus u squared. So our u squared is ln squared x, and then our u is ln x. So we let ln x to be equal to a, that is 1, then sine theta. Okay, guys? So ln x is equal to sine theta. So what is the differential of this? Dx over x. And this is equal to cosine theta d theta. So let's express this in terms of theta. So getting integral of ln squared x dx. So ln squared first. So that is sine squared. Okay, guys? So sine squared theta. What about dx over x? So dx over x, guys, dx over x, that's cosine theta, d theta, all over. So let me move here. I think I need to move this. Yeah. Move a bit. Yeah. So we now have an over this thing. So 1 minus what is ln squared x? That is sine squared theta. Because ln x is sine. So square it, sine squared theta here. Raised to 1/2. So it means square root, no? But what is 1 minus sine squared, guys? That is cosine squared theta, no? So square root of cosine squared theta. Okay? So the numerator is sine squared theta, cosine theta d theta. I can cancel out what? This cosine theta and this cosine theta because square root of cosine squared theta is cosine theta. So what is the remaining now? So this is equal to integral of sine squared theta d theta. So this is under what? Trigonometric transformation. This is basic of even case, no? So that is for sine to the m u cosine to the n u with n0 and m2. So both even, no? So but for cosine, the exponent is 0. Okay, guys? So how do we transform this, guys? Guys, how do we transform that? So this is equal to integral of 1 minus, no? Cosine double the argument. So 2 theta all over 2. Okay, guys? So over 2, all over 2 d theta. Wait a minute. That is 2 theta all over 2 d theta. Yan. So 1 minus cosine 2 theta all over 2 d theta. Okay? So here, I can put the 1/2 out. 1/2 integral of, for the first, we have integral of theta d theta. Second integral is 1/2 integral of cosine theta, 2 theta rather, d theta. I'm going to put here 2 balanced by 1/2 so that this is cosine u du. Okay? So this is equal to 1/2 theta minus 1/4. What is the integral of cosine u du? So that is sine u. My u here is 2 theta. So then plus c. Is that clear, guys? So here sine theta is equal to ln x, but this is sine 2 theta. So I will not able to define this in terms of ln x if I'm going to have sine 2 theta. So what is the identity for that, guys? Anong identity of sine 2 theta? That is 2 sine theta cosine theta. So plus c. So getting 1/2 theta minus 1/2 sine theta cosine theta. So let's now define the triangle that is associated here. Oh, this is the triangle. Yeah. Okay. So let this be theta, this part. So sine theta is ln x opposite over 1. Over 1, the hypotenuse is 1. So this gives us square root of what? 1 minus ln squared x. Okay? Oh, so let's now express this in terms of ln x. So 1/2. So how do we define theta? So from here, again, what is sine theta, guys? Ln x. So what is theta? Theta is equal to inverse sine of ln x. No, so we now have here inverse sine of ln x. And you have other 5 options, no? So because you can have here also tangent, cotangent, secant, cosecant, cosine. So you can solve theta from them, and you have an option. You have 5 options, other options for this, no? So minus 1/2 sine theta is ln x. Cosine theta, how do we define cosine theta? Adjacent over hypotenuse. So over 1, no? So plus c. So finally we have 1/2 inverse sine of ln x, or arc sine, no? This is arc sine of ln x, minus 1/2 ln x times square root of 1 minus ln squared x plus c. Okay, guys? Any question with that, guys?
None po, sir.
No question? Are you sure? Guys? Okay, guys.
Wala na po, sir.
No
Wala
question?
na po, sir.
Okay, if you don't have questions, so we can now proceed to the 5th one. Oh, let's have this one. 27 e to the 4x. So again, 27 times e raised to 4x dx. Denominator, we have 9 e to the 2x minus 6 e to the x, and then plus 10 raised to 3/2. Okay? Yan. So first, let us express this expression inside quantity to the 3/2 in terms of either a squared plus u squared, a squared minus u squared, or u squared minus a squared. Whatever form will come out, na? So let's see. Okay? So let's take that. 9 e to the 2x minus 6 e to the x plus 10. I can write this as 9 e to the 2x minus 6 e to the x plus 1 plus 9. Am I correct, guys? And this is equal to 3 e to the x minus 1 quantity squared plus 9. So this is my u. Yeah, this is my u squared. And this is my a squared. So I'm going to let my u to be what? So let u, so this takes the form of a squared plus u squared. So my u, which is this 3, e to the x minus 1, and that is equal to what? A, which is 3, na? And then, since this takes the form a squared plus u squared, so I have tangent here. What's the differential? So 3e to the x dx, because this is 0, this is 3e to the x. I mean 3 times e to the x, and that is equal to 3 secant squared theta d theta. Can you follow, guys?
Opo, sir.
Yes po, sir.
So we have 27, na? So 27. Let me put that out. 27 integral of e to the 4x, e to raise to 4x. What is that? So from here, so where will I get the value of that, guys? So remember, my u is 3e to the x, na? Okay? So I can express this e to the 4x as what? 3e to the x. Let me express that first as 3 so that you can clearly see. 3e to the x quantity 3 quantity cubed, and then e to the x dx, because I have here e to the x dx, times what? So times, i-times ko siya ng, kasi may 3 tong, I think I can simplify this. But let me simplify first this one, this e to the x dx. And then this 27 later, I think I need that as a base, part of the base. Let me erase this because I can still simplify this one. E to the x dx is equal to 3, secant squared theta d theta. Yan. So that we now have this integral integral of this 27 e to the 4x. I can write that 3, na? 3 e to the x raised to 3, that is 27 e raised to 3x times e to the x dx, which I will use for e here, e to the x dx, na? All over this part, which is now equal to this inside this one, this part is now equal to what, guys? This part, this is equal to this, na? So that is u squared. But what is my u? This quantity. So u is squared. So I will square this. So that is 9 tangent squared theta. Okay? So again, this is equal to this. U squared plus a squared. My a squared is 9 raised to 3 halves. But what is my 3e to the x, guys? Guys, because this is 27, no? 27 e to the, remember this is 27 e to the 3x times e to the x, giving this quantity, no? So 3e to the x means this quantity, 3 e to the x. So I will put this negative one here, so plus. Okay? So giving 3 tangent theta plus 1, this part, 3 tangent theta plus 1 is 3 e to the x raised to 3. Yan, raised to 3. E to the x dx is secant squared. Oh, that's it. Over this quantity. This is 9 times 1 plus tangent squared, or 9 times tangent squared plus 1. But what is tangent squared plus 1? That is secant squared. Secant squared times 9. And this is raised to 3 halves. Getting, guys, integral of 3 tangent. Yan. I have to take note of these things that we're doing, because this is what you're going to have. Secant squared theta, you're going to do this also. All over, what is the square root of 9? Secant squared, that is 3 secant theta. Cube it, 27. Secant cubed theta. Oh, I can cancel this out. There is a remaining 1 here, secant theta, because this is secant squared theta, so there is a remaining secant here. So, and this is what, guys? 1 over 27 integral of 3 tangent theta plus 1 raised to 3 over, what is the remaining here? Secant theta. So d theta. Okay? So how are we going to evaluate this integral? We have no choice, because tangent is not directly related here, because if I bring this up, cosine, tangent, remember, is related to secant squared, or its derivative, no? So let's cube this and then bring this up later, no? Or perhaps we can have division term by term. 1 over 27. So after expansion here, integral of, what is the expansion? Cube the first, 27 tangent cube theta plus the square of the first, 9 tangent squared theta times the second plus 3 times 3 to, no? So what is 3 times 3? 27. Kasi cube the first plus 3 times the square of this. So I have 27 for the second term. So again, cube the first. So this is the formula, a cubed plus 3a squared b plus 3ab squared plus b cubed. So we have 3 times 9, 27, tangent squared. 3 squared the first times the second. Second is 1, still 1, no? Plus 3 times the first, so that is now 9. 3 times 3 tangent theta, that is 9 tangent theta, times the square of the second, so 1 will not affect, plus the cube of the second. Oh, that's it. D theta all over, this is a long division. I mean a long fraction. Oops. All over secant theta. Let's divide 1 by 1. So 1 over 27 times 27 here. So that is now tangent what? Cube theta over secant theta. Over secant theta. Okay, guys? So this is actually case 5. Add exponent per tangent. This is when I bring it up, secant theta quantity to the -1. So, and if it is case 5, we consider only for the exponent of tangent. Then the second one, 27 over 27. So 1 tangent squared theta over secant theta. Guys, so again, that is tangent squared theta over d theta. I'm worrying about you guys actually. I do not know if you will able to do this thing, no? But that's life. This is what engineering students have to do. So even in face-to-face, this is, you cannot escape from this, no? 9 over 27, that is 1/3. Am I correct, guys? 1/3. This time, tangent over secant. So integral of tangent, theta, d theta, over secant. Okay, guys. Is there a remaining one? Yes, there is one more, no? Plus integral of, so this is, where am I now? 1 over 27. Am I now in 1 over 27? Kasi 9 over 27, 1 over 27. 1 over 27 integral of d theta over secant, no? But when you bring this up, cosine is the easiest to integrate among this integral. Okay, so let's now, I think I need to copy this pieces of integrals because I will be moving to the next slide. Yan. And let me copy this part, bring this here. Okay. Oh, let's now work on the first integral, guys. Integral of. Siguro one item will be worth 100 points. So there are a lot of integrals. Again, this is case what? Case 5. We transform this into tangent squared theta. And then we're going to have, from here, I will get secant, no? Pag kumuha ko ng secant dito, anong mangyayari? So, kukuha ko ng isang tangent, isang secant. Anong matitira sa ilalim? Guys, dahil kumuha ko ng isang secant dito, magiging secant squared. Ito kakaiba, no? Nagsisimplify pa nga tayo. Ito, nagdagdag pa tayo ng secant. Secant over secant squared theta is 1 over secant. Then times tangent. What's the purpose again, guys? Para secant theta, tangent theta, pag case 5, so d theta, so you have to express this in terms of secant. This will serve as the derivative of secant. This part, no? Times d theta for the differential of secant theta. Okay? So, and then this secant squared theta, when you bring it up to the negative, you are going to distribute inside to the transformation of this. No? So the second integral, that is secant squared theta manipulation. No, hindi yan case 5 because this is even. For case 5, it must be add. So -1, that is tangent squared theta. All over secant theta, we can divide that term by term. Then plus 1/3. Oh, what about this, guys? What is tangent theta? Tangent theta is sine over cosine. Again, sine over cosine. Yan, sine theta over cosine theta. Times 1 over secant is cosine. O, this is cancelled out. O, what is now the remaining? It is simply sine theta. O, see? Sine theta in other form is this, no? Plus 1 over 27, guys. And this is integral of cosine theta. Oh, almost everything is ready for integration. Integral of this secant, we have to bring it up, the secant squared. This is now secant squared theta minus 1. And this is, again, secant theta raised to negative 2. And then secant theta tangent theta, nakakauta, d theta, plus integral of secant squared over secant is secant. Parang nag-reunion na lahat dito. Reunion of mga integrals for integral form. 1 over cos, 1 over secant is cosine, no? So cosine theta d theta plus, what's the integral? 1/3 negative, no? Negative 1/3 cosine theta. Again, integral of sine is negative times 1/3. So negative 1/3 cosine theta plus 1 over 27 sine theta. We're going to have plus C later because there are still integrals. O secant times secant to the negative 2 times secant squared theta, that is 1 times this. Secant theta tangent theta d theta, that is basic integration. Guys, okay? So we now have minus secant quantity to the negative 2 times this. Actually, pag minultiply ko ito dito, magiging ilan? Guys, pwedeng yan na rin, actually. Kung ayaw nyo, this is just secant. Yan. Theta raised to what? To negative 2. Ito yung differential niya. This is the differential. Tulog na yata kayo. Are you now sleeping, guys? Guys.
Po, sir.
Oh, yeah. Don't worry. You're not the one who is solving. No? I am the one solving. You're just listening. And I do not know if you're really reasoning. Sine theta minus 1/3 di copy. Cosine theta plus 1 over 27 sine theta. Kailan kaya ito matapos? Tatapos sa 130. So this is secant theta. This integral. Integral of secant theta tangent theta d theta is secant theta. U to the n du. U to the n du. U to the n plus 1. So this is negative 1 over negative 1. So plus secant theta quantity to the negative 1 is cosine. Am I correct, children? And why is it now positive? Minus secant theta raised to negative 1 over negative 1 because plus 1 eh. U to the n du. Then plus, yan. So gradual, getting to simpler form. Then minus sine theta plus 1 over sine theta. I mean 1 over 27 of times sine theta. What is that? So 27 over 27. So negative 26. Tama ba? Negative 26 over 27 sine theta minus 1/3 yan cosine theta. Yan. We're now close. Plus C. Okay, all you have to do is to express everything in terms of its value, in terms of the original function. Let's now do that, guys. Meron pa palang pwede i-combine, no? Combine na natin. Ay, combine muna natin. Ito, this part and this part. Secant theta, 3 over 3 plus 1 over 3 plus 1 plus negative 1/3. That is 2/3. 2/3 cosine theta. Am I correct, guys? This part and this part. Hindi naman kayo nasagot eh. Let's begin with this. Minus 26. So let's start everything with simple terms. No? Followed by this ln of secant theta plus tangent theta, then plus c. Okay. Okay, guys. Let's now replace. What is secant? We have to draw triangle. I'm going to draw na lang here. Yan. And this triangle. What are the parts, children? What is our tangent? 3e to the x minus 1 all over 3. Tangent. 3 e to the x minus 1 all over 3. Am I correct? 3 e to the x minus 1 all over 3. That is tangent. Opposite over adjacent. And then here is square root of. Square of this is square of this. Add. Actually, it will give us 9 e to the 2x minus 6 e to the x, then minus 3 here, then plus 9. Ilan lahat yun? Pag in-square ko to, 9 plus negative 1 plus 10. Tapos ito, in-square ko to, 9 e to the 2x minus 2 times 3 e to the x, 6 e to the x, so plus 10, negative 1 plus 9, ay 1 plus 9 pala, sorry. When squared 1 plus 1 to plus 3, 9. Okay. Yan. Let's now substitute. What is secant theta, children? Radical, no? Square root of 9 e to the 2x minus 6 e to the x plus 10. I'm going to copy this because I'm going to write, I think, this again. Okay, copy. Over adjacent minus, plus 2/3 cosine square root, not yet, 3 over square root. Control copy, control V. Yan. See? So that I'm not going to write again, because I have anticipated that I'm going to write such expression. Minus 26 over 27 times. That is sine, no? Opposite over. Yeah. This radical. Copy. Put the radical here. Go there. Yeah. And then we have in the numerator this, no, sine. So sine opposite over, if this is my theta, e to the x minus 1. And then finally, ito na lang, ln of secant. We have that secant already. Secant plus tangent. So secant, this over this. Tangent, this over this. And this, I think it will not, this over, they have the same denominator, no? Secant and tangent, secant tangent, this over this, ay this over this plus this over this. So plus, plus 3 e to the x minus 1 all over, same no? All over 3. Plus silang over 3 plus c. O, yan na. O, that's it. Okay? Meron ba akong na-miss, children? So, simplify nyo lang. Actually, hindi pa yan ang simplified form. Simplify lang natin. Do you have class, guys? Cancel na yan. And then, I will just copy this everything. So, here. Yeah. So, I can now write this as this radius. Ay, sorry. I think copy that. Just fix, no? What will I remove? This part. I will now remove this. And then just have this quantity. Yan here. And then just 2 in the numerator. Check what I am writing, huh? And then we'll have this. Yeah. And I don't think we will able to simplify this more. So that's it. Okay, I will just write this in a better form. So I will have just one denominator. I'm just fixing. Enough. And we'll now have over 27 times 26 here. Okay? Yan. I can combine this 26 with this. And let us have plus c here. Yan. Yan. Remove this. By the way, you have ln of this numerator minus ln3. ln minus ln3 actually can be incorporated or can be included in the c here. So that I will just have, guys, plus ln of square root of, yan, absolute value to, no? Before absolute value also. But absolute value of ln3 is still ln3. That is minus ln3. Can be included in the C. So I will just have this 9 e to the 2x minus 6 e to the x plus 10, and then plus 3 e to the x minus 1. Again, minus ln3 plus c, let it be c1, where c1 is equal to c plus ln3. Because this is already accepted, no? But if let's say you solve from foreign books, and you will see sometimes that the answer is not this. So because you might be surprised why you don't have, for instance, mistake, but you can't see your answer different entirely, no? Or for this case, there is no ln, there is no 3 here because it is incorporated or associated with c. Because ln3, negative ln3 is constant. You can put it with a c. Is that clear, guys? Guys, may na-miss ba ako, guys? Paki-check before we leave. Guys, guys, if I'm going to combine this 2 times plus 26, over 27, yun na lang ang actually co-combine nyo. Okay, guys? You may leave now if you want. So, I will just combine that so that when I record complete, 2 plus 26 divided by 27, that is, I think, 81. Again, 2 plus 26 divided by 27. $80 over 27. And you will now have 26 times 3. And then 26 divided by 3. I will combine that to a third. This one. I can combine this. Pag ni-rationalize ko to, I will have 9 e to the 2x minus 6 e to the x plus 10 all over 3 square root of 9 e to the 2x minus 6x 6 e to the x plus 10. You can leave now, guys, if you want. I will just finish this so that the recording is complete. Plus, I will just copy everything. So this is LCD is 27. Square root of 9 e to the 2x minus 6 e to the x plus 10. This is 27 divided by 3. That is 9 times 9, 81. 81 e to the 2x. Then minus 27 divided by 3 is 9. 9 times negative 6. Then plus negative 26 times 3. That is 132 negative e to the x. This and this. Then plus 10. And 27 divided by 3 is 9 times 10. 90. Then plus 27 divided by 1 is 27 times 2. So plus 2 times 27. Then plus 26. Same denominator, so plus 26. Getting 134. Again, let me check that. 27 divided by 3, 9 times 10 plus 27 divided by 1 times 27 times 2 plus 26 plus 26. So that is plus 170. Then plus this thing, ln of square root of 9 e to the 2x minus 6 e to the x plus 10 plus 3 e to the x minus 1. Absolute value plus c sub 1. So that's it. Okay? So again, let me check for the constant. This is 10. So 27 divided by 3 times 10 plus 27 divided by 1 times 2 plus 26 equals 27 times 27 divided by 3 times 10 plus 2 times 27 plus 26 equals, so for the constant, 170. Okay. So that's the final answer. So that's for today.